Hello everyone, welcome to this video. In this video, we are going to solve question from December 2016 consisting of 3 marks. The question is, g of y is given to be integration from 1 to 2 y dash square plus 2y dash plus y square dx, where y at 1 is given to be 1 and y at 2 is arbitrary. That is, it can take any value where the x is specified to be 2. Then what is the extremal among these four? So let us get started. First of all, we have to solve the Euler-Lagrange equation. What is that? That is f of y minus d dt of fy dash is equal to 0. So in this case, this is our f, right? So let us calculate fy, the partial derivative of f with respect to y. So that would be 0 plus 2y dash plus 2y minus d dt fy dash. What is the derivative with respect to y dash? It is 2y dash plus 2y is equal to 0. I can take common out. So I'll be left with y dash plus y minus, let me differentiate this with respect to x. Here it should be x because the independent variable here is x, right? So y dash plus y minus the derivative of y dash with respect to x, it is y double dash minus y dash. So it is equal to 0. So this term cancels with this term. So I am left with y double dash minus y is equal to 0. So this is the second order differential equation whose auxiliary equation could be written as d square minus 1 is equal to 0. So this gives me d is equal to plus minus 1. So our solution y, it becomes c1 e to the power x plus c2 e to the power minus x, right? So this is our extremal. Here c1 and c2 are constants which need to be determined. So let us calculate the constants. First of all, let us use this condition where y at 1 is equal to 1 is given. So let us use this. Y at 1 is 1. This implies I am substituting it here in this equation star. So I have 1 is equal to c1 e to the power 1 plus c2 e to the power minus 1. So that would be this. So let me call this as equation number 1. Second condition is given that y of 2 is arbitrary. What does it mean? It means that y can have any value where x is fixed and given to be 2. So for that we have a condition known as fy, which is fy dash at the point x2 is equal to 0. So let us solve this. What is fy dash? The given f is this. So fy dash would be 2y dash plus 2y, right? So 2y dash plus 2y at the point x2. What is x2? It is given to be 2. x2 is equal to 2 is equal to 0. So we have y dash plus y at the point x is equal to 2 is equal to 0. So we have y as this. What is y dash? Let us compute it. So y dash would be c1 e to the power x minus c2 e to the power minus x. So let us put these values here. So we get c1 e to the power x minus c2 e to the power minus x plus c1 e to the power x plus c2 e to the power minus x at the point x is equal to 2 is equal to 0. So here this term cancels with this term. So I am left with 2 c1 e to the power x at the point x is equal to 2 is 0, or I have 2 c1 e square is equal to 0. So this gives me c1 as 0 because the function e cannot be 0, 2 cannot be 0. So only c1 could be 0. So let me substitute this value of c1 in equation number 1. So put this in 1. What would we have? We'll obtain 1 is equal to 0 plus C2 by E. So this gives me C2 is equal to E, right? So I have both C1 and C2. Let me put these two back into the equation star. So what I have is y of x is equal to 0 plus e into e to the power minus x, or I can write it as e to the power 1. So this would be e to the power 1 minus x. So this is the required value of extremal. So let's have a look at the options. So clearly option C is the correct option. So option C is the correct option. So this was a very simple question. What you needed to know in this question was that it should have for a fixed boundary there was no problem. You can directly use the Euler-Lagrange equation. But the second boundary was moving where in the vertical direction where x was 2. So in that case you need some other condition imposed on this point. So that was this, right? Thank you for watching the video. Please like, subscribe,